Following on from my Dan in a Van episode 6, where I talked about fixing stuff, I've got my H&H VS Musician amplifier here. These were the famous ones that lit up green when you switched them on back in the 70s. And the reason I'm going to choose this one to show you about the components of an amplifier is it's beautifully built and it's easy to see every single component. And I'm going to explain basically everything that happens from the mains input to the power supply that supplies all the components on the circuit board. Now, it is a major part of any electronic bit of kit, the power supply. And I'm going to explain how that works. I'm going to bring the camera down so that you can see in fine detail what's going on. And I'm going to draw a few pictures as well. So this is the amplifier with the top off. I've got a little multimeter here which is sort of flickering about with some figures. And I'm going to show you basically all the component parts of what's happening. Now, let's have a look first at the top right. This is where the power comes into the unit. Now, this amplifier is switched on, so you've got to be very, very careful when you're prodding about with power supplies, because if it bites you, it's not very nice. Now, I'm going to put my negative probe on the case of the amp, and then I'm going to look at the fuse here. And if you look on the multimeter bottom right, you can see that there are 236.2 of your English volts there. Now that's quite high. If you touch that, that's not nice. Now, this piece here, this is the transformer. Now, what a transformer does in a transistor amp is to step the voltage down. So it takes the mains voltage and turns it into something smaller. Now, the reason I said transistor amp is because valve amps, usually you need actually a higher voltage, so that transformer steps up instead. But the principle is virtually the same. Now, we have, after this transformer here, there's a little unit here. You can see these little blue sort of push-fit connectors here. This is called a diode bridge. Now, what the diode bridge does in conjunction with these two big sort of bluey green cans here is that they smooth the AC voltage down to a DC one. Now, what I mean by that is, well, let's have a look first of all at the diode bridge. So on my multimeter, bottom right, you can see that the transformer is outputting 70 volts instead of 240. So it's stepped down by a factor of 3 and a bit. Now, the other two pins on this diode bridge are your DC power supplies, and they are directly connected to your capacitors here. So I'm going to switch my multimeter to DC volts now. Still with a probe on the case here, I'm going to look at the red one first, which should give me roughly 50 volts, give or take. There we go, 47.54, and then the other one will be a minus value of roughly the same. There we go, pretty much exactly the same. Now, at the moment you can see on the multimeter that I've selected DC volts. So the diode bridge and the capacitors between them have turned an AC voltage into a DC one, which will then feed your power amp. Now, I'm just going to also, while I'm here, check the condition of that DC voltage, because you don't want any AC component on the DC voltage. Now, I'm going to draw a few pictures in a minute so that you can see basically what's happening, and I can sort of run through it again, but with a diagram. So let's have a look at the negative power supply first. Yeah, as you can see, there are only 24 millivolts of AC volts on there. That's fine, absolutely fine. Let's have a quick look at the other one. Yeah, essentially the same. You have to wait for the meter to settle down, because this one also does like an auto ranging, so it'll make sure that you've got your it'll settle down first and give you the correct value without you having to twist the dial. So we've got a transformer, a diode bridge and some capacitors, which then give you two voltages. I'm now going to explain on a piece of paper how that works, and I'm going to do it without any maths at all, because I think it's important that, given that the power supply is responsible for so many problems inside things like amplifiers, it's a good idea just to have a little handle on what's going on. Now I've got a piece of paper here, and I'm going to sort of try and explain things in a pictorial fashion, but with still the components showing, and I'll point those out as well. Now in the top right we had the mains coming in, so we had a live, a neutral and an earth. Now the live is usually brown, the neutral is usually blue, and the green is the earth. Now the earth is directly connected to the case of the amplifier as shown there. Now the live goes through a fuse, which is that little component top right that we just saw just now. I think it's 1.6 amps on this. And it's called an anti-surge fuse. There are two types, there's fast blow and anti-surge. Anti-surge is what you would find on most mains equipment, but fast blow exists on things like valve amps and speaker fuses and that sort of thing. So live and neutral are connected to the transformer, which looks like this. The two vertical lines represent the iron, the ferrite core of the transformer. So we have live and neutral coming in, and electricity looks like this. If you were to see it coming out of the wall, it does that 50 times a second, or 60 if you're in the US. Now as we saw, the input was 240 volts and the output was, I think, 70 if I recall. Yeah. Now that means that we've got the same thing but a smaller version, like that. So that has stepped down the mains to something a little bit smaller. And there's the output of your transformer. Now we come to the diode bridge. Now this is 4 diodes arranged in a triangle, like so. And then the other points, this is your plus voltage, which we saw as 48 point something, 48 volts, and minus 48 volts on the other side. So there's your minus voltage, and the minus voltage comes off the other side of the diode bridge. These aren't connected. This wire goes over the top of that one. And then in between these two voltage rails, we have those two big cans here, those sort of turquoisey cans, which are called capacitors. Now they're called electrolytic capacitors, so they need to be connected around the right way or they explode. I've seen it happen. It's quite cool, but very dangerous. So, and then in the middle we have 0 volts. Now that wire is also connected to your ground, to your mains ground here. So what happens here, let's consider the following scenario. The voltage, if we imagine that there's a 0 line in the middle, which means 0 volts, the voltage is a massive plus swing and then a massive minus one. Now voltage is essentially the way the diodes work is that they only allow current to go one way through a piece of kit. So when this voltage is plus, it will essentially be allowed to pass through this diode. It won't go back the other way. Now that's really important because it actually has a massive effect on how a power supply works. So if we've got something like plus 70 volts, you do get a tiny bit of a drop across a diode to the tune of about 1 volt. Well, it's actually about 0.7, but that's fine. That's fine. Now, what we've basically got is a scenario where you have a diode that is allowed to go this way, and then your other diodes are arranged thus. Some amplifiers will have 4 actual discrete diodes in a network, but this has got a block with 4 tags coming out of it. So 1, 2, 3 and 4, and then all the diodes are internal. Now what happens here is that when this voltage is high, it's allowed to pass through here, and also because the voltage is high there, it will be low here. By definition, if the voltage is higher there, it'll be the opposite way round there. which means that it's lower than this. So the current is allowed to pass through there. So these two diodes are operating, but these two are not. But if we switch that round the other way, and this is low and this is high, it means that the voltage will continue to go through there, that diode, and then the minus voltage will go the other way. So what happens is that these diodes are switching on and off, allowing a positive voltage here and a negative voltage here. Now, as I said before, these aren't AC voltages anymore, they're big DC voltages. So you've got these power rails here. So I'll just move the paper along slightly. Now, the idea here, you think, well, why do you have a DC and an AC and all that? Well, the amplifier, any amplifier, electrical amplifier, will amplify will amplify AC signals, but within two particular power rails. So there's your music that's coming through, whatever, you know, it won't look like that, but it's basically just like a waveform. 0 is like silence, and then the maximum deviation is 48 volts, and the minimum, or rather the maximum deviation, is actually 96 volts when you look at it. And basically what happens is if an amp goes into distortion, it's because you've put too much signal through, that it goes higher than the power supply rating, and you end up with a flat top like that. And that's where you get distortion, and that can be a nice effect, but it can be problematic because you're asking the transistors inside this amp to do rather more than they're designed to do. So there are your two voltages. Now, what actually happens inside an amplifier like this is that there is a secondary power supply which is derived from the main one. So we might have plus 15 volts and minus 15 volts. And what that does, and with a 0 line as well, what that does is it powers the smaller components, like the little 8-legged integrated circuits that will then allow your power amp to be fed by a preamp. Now, for an explanation of these diodes, because this is the bit that people go, oh, wait, hang on. There is a link in the box below to a very, very good analogy. And it's a guy who's made one of these, who's made a diode bridge, but using water and syringes so that you can see the effect of what it actually does. So there is a sort of an explanation of all the bits and pieces that you get in a power supply. What usually happens at the end of the life of these capacitors, because they don't last forever, these have been replaced over the years, is that you actually end up getting a bit of AC here, a little bit of AC on your power supply, and that manifests itself as hum through your speakers. So if you've got a power amp that's humming a lot, it could be that the capacitors are tired, and it's usually those. The diode bridge lasts forever. The transformer, they hardly ever go wrong. This is the original one from January 1977, and I was just about to turn 3 then, and I'm getting on now, but it seems like the transformer is actually happy to play for another 40 years. Anyway, there we go. There's a component power supply for you to see.